hoped to be able to do a recording with my face floating in some corner of this, but unfortunately that proved to be a bit difficult to do at the last minute. Good afternoon. Happy to see all of you here today. My talk's called Emacs, the Editor for the Next 40 Years. It's a follow-up of an earlier talk that I did, both at the University of Pennsylvania and then later for the New York City Emacs meetup. To begin, it's been a while that I've been doing this thing. I originally learned Emacs in September of 1983. It's now November 2019, so that's 36 years, which is sort of a crazy period of time to have been using a piece of software. Kind of an amazingly long time when you think about it. And here we are, spending all day watching talks about a text editor? Like, what sort of nuts are we? I mean, why would anyone do that? Clearly, we're all hooked. We think Emacs is a critical tool for our work, and we care a lot about Emacs, and we care a lot about making sure that Emacs continues to be a good tool for our work and improves with time. But will future generations of hackers also get hooked on Emacs? That is the question that I'm going to ask and sort of answer in our talk today. So this talk is a call to action. I gave a talk, as I mentioned, in April 2013, which was the 30th anniversary, more or less, of my using Emacs. And then I repeated it about a year later for the New York City Emacs Club, where it got recorded. And it is out on YouTube where you can look at it. It's pretty easy to find a copy of. And you will notice something interesting, which is that there are 114,000 views of the thing, which was not something that I was really expecting at all. But I think I hit a nerve with this talk. I'm not going to repeat the talk today because, you know, if you want to watch it, and in fact you should watch it, I think, even if I did it, it's online. It's not the best version of that talk possible. The audience got a little bit boisterous, but there's some stuff that relates to today's topic that's in it. And I'm sort of assuming that the people watching today's talk are at least reasonably familiar with what was in the previous talk. If you haven't seen the previous talk, please do. But the topic today is going to be an expansion of one section of that talk, which is, more or less, can Emacs survive another 40 years? Can it reach, you know, its 80th or even 100th anniversary? And my answer is, not surprisingly, because otherwise why would I be bothering to talk to you today? Yes, but I contend that to do that, it needs to remain the best tool for future hackers to do their work day to day. And so what I'm going to be discussing today is what Emacs can do to adapt itself to the requirements of current and future developers so that it remains relevant. Now, Emacs is, as we've noted, as computer software goes, a really old tool. It was written for a very different world. This was the best way to use Emacs when I got started. This is an actual terminal for those of you too young to recognize such things. This is a VT100, 80 character by 24 character display, connected by an RS-232 serial connector to some mainframe. In this case, it was connected to DEC System 20. This terminal is now a museum piece. No one in their right mind would still use such a thing. And yet we still use Emacs. The operating system that I used when I started working with Emacs was TOPS 20, which ran on a DEC System 20, which is a pretty obsolete piece of software. I don't miss using Tops 20. Maybe there are some people out there who do. Yeah, I don't. I rather like the fact that I use a modern machine with a high-resolution display, a graphical user interface, all the windows I want, etc., and gigabytes of memory instead of, as that machine had, around a megabyte of memory, shared across all of its users. Emacs used to be written in Tico. For those of you who don't know, this is an example of actual Tico code. Yes, it looks like line noise. This is not a joke. This is what people actually had to use when they were writing Emacs stuff back in the day. And so the move to eLisp was, in fact, a big improvement for everyone. So Emacs has evolved a lot over the years. It has moved from being something written in Tico, running on DEC PDP-10s, into something that is written in C and using eLisp as its extension language, which runs on a variety of modern platforms. It does all sorts of things that the older version did not do. And some of the change that has happened was pretty abrupt. The rewrite of Tico Emacs into GNU Emacs was an abrupt change, but mostly these changes over time have been incremental. They've been adaptations. Emacs has changed in 40 years. We've gotten an improved extension language, GUI support, lots of new modes. It can now do networking. But my contention is that if Emacs is going to survive for another 40 years, it needs to continue adapting. It needs to go further. Among other things, which I'll be talking about today, it still has a fairly mediocre extension language. The implementation language for Emacs is not as bad as it was in the old days. In the old days, it was PDP-10 macro assembler, which was what Tico was implemented in. But now it's C, which is also showing its age. Many people out there say that they don't want to use Emacs because they use an operating system already and don't see why they should use more than one. I would contend that every good Emacs user thinks that Emacs being an OS is a great thing. However, it's not enough of an operating system. The threading sucks, and I find myself needing to leave Emacs to do all sorts of things. It needs more integrations. It needs to implement more daily protocols that people have to use. And I'll get into most of this more as this talk continues. Also, for the first time these days, I'd say Emacs is not unique. There are reasonable alternatives that, and I hate to put it this way, but that the kids are using. And many of you, of course, listening today are the kids. I'm not one of the kids, but you guys are, and you're familiar with the fact that, that things do change over the course of decades. Visual Studio Code, which is an open source editor produced by Microsoft, a Libre editor produced by Microsoft, is a pretty good piece of software. It has a big following. It has an extension language. The extension language happens to be JavaScript, but it's still a decent extension language. And generally speaking, as I've looked around, there are relatively few young hackers who are trying Emacs these days, which I would say is a bad thing. I think that Emacs needs to adapt more going forward in order to meet the needs and challenges of the next 40 years. And I'd say there are two kinds of changes that Emacs needs going forward. Now, from the user point of view, all that really matters are the benefits of using the software. Users don't care about what the software is written in, at least not that much. They don't care that much about what's going on behind the scenes, unless they're trying to, of course, hack on the software itself. They care about the features and benefits that the software provides. They care about the fact that they can do refactoring in their editor. They care about the fact that they can process their email in particular efficient ways. They don't care that much about infrastructure. But we as people who are trying to improve Emacs have to care about the infrastructure, because to get important new features, you might find yourself needing new infrastructure. And so I'm going to talk about the infrastructure first, and then what one might do about it second. I've gone through this talk a couple of times in different ways. It's probably a little problematic that I'm discussing the infrastructure first because it doesn't really motivate why you would need the new infrastructure. But trust me for a few minutes on the fact that we do need some new infrastructure, and then we will discuss the sorts of things that one would want to build with that infrastructure. Anyway, there's this famous thought experiment in philosophy called the ship of Theseus. You imagine that you walk into a dry dock and you see proudly on display a ship that is said to have been Theseus's ship from millennia ago. And you find this quite remarkable, and you look at it, and it looks like a lovely example of the shipmaker's craft, except you start asking some questions, and you find out that over the millennia, the ship has rotted in various places, and those places have been lovingly replaced. You know, when boards have rotted, they have been replaced with new boards. When the keel rotted, it was replaced with a new keel. When the rudder rotted, it was replaced with a new rudder. And yet, the docents tell you this is still the ship of Theseus. Well, you know, philosophers like talking about this in terms of the philosophy of identity, and I'm not really interested in talking about that thought experiment for today. What I'm more interested in is that this is something of a development philosophy for how you take a piece of software that's old but that lots of people love, and how you move it forward into the future. And you'll see what I mean as we go on. But what I'm going to advocate for is incrementally replacing parts of Emacs rather than having any sort of radical redesign as happened when it was rewritten in C and ELISP was made the extension language. Emacs has a gigantic code base, and revolutions tend to kill. They kill, especially in the software area, because you lose access to your installed base, where evolution preserves your installed base. Consider org mode. Some of you don't use org mode, but a lot of you do, and it's 120,000 lines of code. That is not a small piece of software. That's something that evolved over a long period of time. It's not going to get rewritten overnight. Starting afresh without any regard for the past means you initially have no users. And no users means that you initially have no people developing your open source software except for yourself and some other people that you con into it. But that means that it is harder to get interesting features developed because you don't have that larger developer community, which means that it's harder to get users, which means that it's harder to get developers, which means that it's harder to get users. And so starting with an existing piece of software and not throwing it away is often a much easier way to get improvement than starting completely afresh. So I propose, as with the ship of Theseus incrementally being changed from a 2,000-year-old ship to a ship that looks pretty similar but is made from modern timber, that we take Emacs and we incrementally improve it over a course of years. Now, ELISP is a fairly old extension language at this point. It's decades old. That doesn't mean that it's complete crap, but it does mean that it's behind the times in all sorts of ways. Now, some improvements have been made over time. ELISP finally has lexical scope. Lexical scope is a significant improvement, but, you know, the APIs provided by ELISP are awful because they have had to retain backward compatibility over a long period of time with very, very slow deprecations. And when ELISP was created, people didn't really know the way that people might want to use it decades hence. ELISP doesn't have a particularly good module system. In fact, it really basically has no module system. It has a threading system now, which is hackish and unsafe. You know, you don't have guarantees that two threads will not trample over each other while they are running. ELISP is also not a particularly good Lisp. People write in ELISP in an extremely imperative style, and they also write in ELISP in a very kind of brute force style. ELISP doesn't even do things like proper tail recursion, so far as I know. Elisp kind of needs a refresh at this point. But again, if you were to replace Elisp overnight, you would lose your installed base of millions of lines of really useful software. The solution, I think, here is to build a new, better extension language that runs in parallel with Elisp. Don't throw Elisp away. Provide a better alternative that people can use while Elisp still remains supported. Now, is this crazy? No. You can have a second extension language that uses the same runtime that Elisp uses. Most of the Emacs C code can be thought of as providing a runtime for Elisp to run in. The runtime is okay-ish. It's nothing spectacular, but it's fine. And if you share it between Elisp and a new language, you get easy ability to call between the old language and the new, which is a good thing. You can create a new extension language, encourage new code to be written in the newer and better language, but protect the installed base by indefinitely supporting the old extension language. Now, what would I propose that such an extension language look like? That's a more speculative sort of discussion. I think that it should be a Lisp, both for comfort and to make interoperation with Elisp easier. You want to have a relatively similar programming paradigm. I think that it needs to provide strong concurrency safety guarantees. I'll discuss why as we go on, but I think that that's a thing that Elisp does not do currently and cannot easily do currently. I also think, and this is going to be a controversial idea, especially to people who don't think of Lisps as being something that you can have strongly typed, that the Elisp replacement should be strongly typed, because type systems make development much, much easier. For people who grew up, in the programming languages area of, 30, 40 years ago, type systems were bothersome and got in your way and made your life harder for the most part. And Lisp systems were dynamically typed, and this was a good thing because it made it easier to develop code fast and comfortably. I would say that that situation has now reversed itself over the decades. It is now the case that strong type systems make it much easier to write code quickly and comfortably, because they no longer get in your way, and they provide a great deal of support for the programmer for programming in the large and not making lots and lots of nasty mistakes. We can discuss that maybe a bit during the Q&A. How does one get from here to there? I think that a new extension language needs to be developed incrementally and with an experimentation, with experimentation as being the watchword. Really good languages are not created in one shot. It takes time to figure out how to create a new language that's worthwhile. People have to play around with the stuff for a while in order to get anywhere. I also think that these days, and this is probably something that is not that controversial among the people in the know, but is probably unexpected for the people who aren't, the theory of programming languages has gone from an aesthetic study 30 or 40 years ago to being a really, really, really engineering and mathematically focused discipline over recent decades. And it is worth talking to PL theory people if you want to do anything new in terms of programming language design. So I would encourage turning to programming language theory people to help with the design of a new extension language for Emacs. They know important things. And it is important to consult them. And I will note that many programming language theory people really love Emacs. I work with a lot of PL theory people, and many of them use Emacs for almost everything. And so hooking a bunch of PL theory people into helping with Emacs might not be the hardest thing on earth. So anyway, moving on, a quick note on performance. Emacs has gotten relatively slow of late. it is straightforward to make Emacs run very, very slowly. Opening large files, especially large files where there's various kinds of highlighting and syntax highlighting, etc., needed, tends to be extremely slow. Keyboard macros have gotten slower and slower. All sorts of things have gotten relatively slow. I would recommend that JITting, or otherwise compiling a new extension language, would be something that people would ultimately want to do. And if we have a typed extension language, compiled code will really, really, really scream. Portable compilers are now easier than ever. Building a compiler that one could easily package up with Emacs and expect to run on most operating systems and most microprocessor architectures is easier than ever before. Anyway, back to my notes on concurrency. We now live in a parallel world. Single-threaded CPU performance has been stalled out for years now. Laptops with 8 and more cores are now common. Desktops with 32 cores in a single on a single chip are now available. Servers with hundreds of cores appear. I do a lot of my work day to day on a machine with 128 threads on it. This is the way that the world now works. My prediction is that good programming models for parallel and concurrent code are critical to future software. If you want to build successful software in the future, it's got to be able to make use of many processors, because machines going forward will have many processors as a rule, not as an exception. And that includes Emacs. Now, if you're watching a video of a tutorial on the web in Emacs, while you're refactoring a program and checking your mail, and your calendar is checking for reminders to remind you of, and you have a chat window running and other things like this, you'd better be able to deal with concurrency well. And concurrency is notoriously hard for programmers to get right. It's a thing that people muff all the time. So far, I think that the only programming language that I've seen, and actually this is a lie, Erlang does pretty damn well, and maybe an Erlang-like model is better than a Rust model. And probably I should have cited Erlang on a slide here too. But let's say that Rust and Erlang are two of the only languages you can name that have a really good concurrency story these days. Emacs's extension language and internal architecture probably need to handle concurrency in a trouble-free manner for the programmer, or we're going to find people routinely seeing their Emacs's crash or hang with concurrency screws. And that means that we need careful design of our concurrency architecture. Some of the world's best minds have struggled to design good concurrency architectures. It's important to think about this carefully. It's important to consult theory people, and it's important to work slowly if you want to build a good concurrency system. I think that the threading work that's been done on Emacs so far has been a lot more experimental than that. And I would say that a new concurrency model for Emacs, a new extension language, and a new implementation and architecture changes need to be considered together to really do a good job of this. Probably not something to rush. Anyway, onto another topic. There's the question of the implementation language in which Emacs itself is written. And Emacs is written not only in eLisp, but in C. In some sense, eLisp is implemented in C, and Emacs is implemented in eLisp. And C is, these days, a dying language. C has hundreds of forms of undefined behavior. If your program invokes any of these forms of undefined behavior, and it's really hard not to invoke one of them, you find yourself in a world of pain. One of the results of this is that in recent years, people have discovered that C programs can't really be written safely by mortals. And if you are listening to this talk, you are a human being, not a god. I know that some of you probably say, oh, all you need to do is be sufficiently careful. It's only the bad programmers who can't write safe C code. And I will be blunt, I don't believe or agree with you. And we can talk during the Q&A about why I think this is if you disagree. And I can point you at lots and lots of examples and papers for why this is true. It is also the case that C has relatively few features for modern programming. People these days like things like parametric and ad hoc polymorphism when they are writing programs. They like to be able to make use of good code reuse. They like to be able to, modularize their code. C makes a lot of this stuff relatively hard. I would contend that in the medium term, C probably has to go for Emacs to survive in the long run. Is C a crisis for Emacs? Not quite yet. However, having a creaky implementation language slows Emacs's evolution. It is harder to debug Emacs because it is written in C these days. It is harder to write good code. It also means that there are fewer people who are willing to contribute code to the base level of Emacs because you need to be able to write code in a relatively hard to deal with systems language in order to contribute to the base of Emacs. That means that it is harder to contribute to Emacs, which means that fewer people do. I recommend that the Emacs implementation language be fixed before it becomes a crisis, because it's going to take a long time to do, and the longer you have to do a hard project, the more likely it is that you will complete it before it becomes a problem. What would be a good new language to write Emacs in? My guess is Rust. There might be other options. I'm happy to discuss them during the Q&A. I think that Rust is the most practical option for now. Why? Because it's the only fully safe systems programming language that I know of in existence. It provides as much control as C has. It provides easy interoperation with C, and yet it is fully safe. Rust has a fully safe type system. You cannot write programs that violate the type discipline in Rust. There are no buffer overflows possible in Rust. It is not possible to accidentally cast one thing to another in Rust without knowing what you are doing. Even concurrency is guaranteed safe by the Rust compiler. It is not possible to accidentally share a piece of data between two threads in Rust and have one trample over that piece of data while another thread is trying to read it. The Rust compiler statically guarantees that this is not something that can happen. That's pretty impressive, I think. You can still write low-level code in Rust. You tell Rust that you're writing something that's unsafe, and it will let you write things like garbage collectors. You can do pretty much anything in Rust that you can do in C. It's just that most of the time, Rust protects you from yourself. Rust also has all of the bells and whistles people like in modern programming languages. It has parametric polymorphism. It has ad hoc polymorphism. It has a good module system. It is a nice programming language that most people seem to like. This is a long discussion. If people want, again, we can talk about part of it during the Q&A. So my suggestion is that we incrementally replace C with Rust. Provided your language can be called from C easily and can call C easily, which Rust can, you can do an incremental conversion of an old code base. You don't have to replace it all at once. It should be possible to replace sections of the Emacs code base slowly over a period of years. We can treat this like Theseus's ship. We don't have to do everything all at once. We don't have to have some sort of sudden flag day. We don't have to piss off the user community. And I'll note that C and other programming languages will likely have to remain indefinitely in the Emacs code base, because we'll have to be able to call window toolkits, because various pieces of low-level software that we will want to use will continue to be written in C for the very long future, but Rust makes that relatively easy for us to do. Now I'd like to mention some features that we probably need in order to display things that are not text, a thing that Emacs has not been particularly good at over the years. And one of the things one notes when working in Emacs and in a modern environment is that Emacs can't really render web pages. And that Emacs not being able to render web pages is actually a problem. Web rendering is a specialty. It is unlikely that Emacs is going to develop a real faithful web rendering library on its own. We probably need to use other people's web rendering libraries if we want to render web stuff faithfully. Luckily, such libraries like WebKit exist and are Libre software, and we can use them without any real trouble. I will note that there have been attempts to do this already. The XWidgets project appears to be a bit on the stillborn side. That was a nice prototype attempt, but it really makes the web rendering something that's kind of a second-class citizen inside Emacs, something that's kind of hung on the side. And as I'll note, I think that it needs to be deeply integrated in order for it to be really useful for various purposes that I'm going to get into later. By the way, by the same token, I think it would be nice to be able to render PDF, and I will get into why later. But why would you want this, and what sort of features do I mean when I mean deep integration? Here's a typical user story. Let's say that you are looking at a web page or an HTML email message in a buffer. You'd like to be able to iSearch in it, select a region inside of that email message, say with keystrokes, copy it into, copy that region, switch to another buffer, including, say, an HTML email composition buffer, and paste that text into the other buffer. This is a fairly deep problem if you think about the infrastructure you need in order to permit all of that stuff. That's not a hanging HTML rendering on the side of Emacs. That's fairly deeply embedding it into Emacs's structure. Doing this right means being able to view a page with or without JavaScript. I note, for example, that it is typically the case that you want to have JavaScript turned off when you view email messages. It is not safe to have JavaScript on when you view email messages. No normal email viewing program leaves it on. You need to be able to filter which sorts of JavaScript you look at when you're looking at random web pages these days, because you need protection from JavaScript. You might want to turn off non-free JavaScript code. You might want to turn off dangerous JavaScript code. When you're rendering a web page, you may want to filter fetching of various URLs. You might want to selectively filter which images you render, because you might not want, for example, when you're reading an email message, to have web bugs triggered. Web bugs are single pixel size images that people put into email messages in order to track whether or not people are reading those messages and from where. You might not want to be tracked, which means that you need to be able to do things like fairly sophisticated filtering of what does and doesn't get downloaded and rendered. You probably need to be able to walk and modify the DOM, not inside of JavaScript, which is not Emacs's extension language, but inside of the extension language that Emacs provides. You probably want to be able to do all sorts of things. Fairly big project, but also a killer capability for Emacs. Why do we care about this? Modern email is HTML email. I need to be able to see my HTML email the same way my colleagues see it. I know lots of people out there that say, why do you need to do that? It's just fine. You're looking at email in ew mode, or looking at some sort of monospaced text rendering of the HTML, Maybe you can live that way. I cannot. I have no choice. It's not 1992 anymore. I have to see what my colleagues are seeing. I also have to be able to compose things so that my colleagues will see them and see them in ways that they will like. When I develop web pages, I want to be able to view my work in real time as end users are going to see it. I want to be able to view it in my development environment. My development environment is Emacs. There are various kludges that will do things like moving files back and forth into my browser so that I can see things as I'm editing them. They don't always work the best. I would like to be able to do my work inside of Emacs. I want to be able to read programming documentation inside of Emacs, which is all on the web. So I want to be able to read my programming documentation and see it formatted and rendered as the authors intended. And I know some of you are going to say, oh, why do you want to do that? It's just fine looking at things inside of Emacs's janky web browser. No, it isn't. Maybe it's okay for you. It's not okay for me, and it's not okay for a lot of other people. I would like to be able to do chat inside of Emacs. I'd like Libra chat solutions that are as good as Slack and Discord. But modern chat systems that are as good as Slack and Discord generally expect to be able to embed web components. And so if we're ever going to have Libra chat solutions inside of Emacs, we're going to have to be able to do some HTML rendering. I also, generally speaking, just want to be able to surf the web inside Emacs. I hate leaving Emacs. I hate the user interface inside of things like Chrome and Firefox and Safari. But that means that if ultimately I'm going to be able to surf the web inside Emacs, I need Emacs to be a good web browser, which means it's going to need concurrency, good HTML rendering, all sorts of code written in the extension language to make it possible for it to be a good web browser, etc. However, almost all of this stuff is future stuff if we actually begin to get decent web rendering inside of Emacs, and I can read HTML email inside of Emacs, I am going to be really, really, really happy. And I suspect that all of the rest of those capabilities will slowly appear as people leverage the ability to render HTML inside of Emacs and make it do all sorts of other things. Now, as I said, I'd also like to be able to read PDFs inside of Emacs. Why wouldn't you want to read all of your documents inside of your editor? Why wouldn't you want to be able to make notes while you're reading your documents? Why wouldn't you want to be able to iSearch and copy and switch buffers and paste while you're reading PDF just as when you're reading anything else? Not as critical as web rendering, but it would be a very nice thing to have. Now, there's already some support inside Emacs for proportional fonts and various kinds of italic and bold fonts, etc. But lots of Emacs applications probably need this to be shall we say, a better supported use case. There are some times when one is writing things like documentation, and one probably wants to use proportional fonts and do all sorts of other fun things with fonts. When you're doing programming, you absolutely don't want to do such things. It's wildly inappropriate for programming. But Emacs isn't just for programming. Emacs is for manipulating text and writing text in all sorts of situations. Anyway, I've started touching on some of the features that I think that people are going to want inside Emacs, for Emacs to be a really maximally usable environment for geeks over the next 40 years. But let's talk about those things more explicitly for a few minutes. Things that I think that users want or need that could be built on the infrastructure that I have discussed so far. Now, programming is the thing that made Emacs what it is today. Most Emacs users are programmers, and when I gave my last talk a few years ago, Emacs was falling way behind other editors on refactoring and being aware of the symbols in your programs and being able to complete them and being able to pop up documentation and all of the rest. And I am happy to say that a lot of this has changed, and a lot of this has changed because of the language server protocol stuff that has gotten incorporated into Emacs, at least via extensions, and which has been widely adopted by the programming language implementation people. For those that do not know, the language server protocol solves the M by N problem for supporting programming languages in editors. What does it do? LSP is a protocol with which you speak to your language parser. You know, some people realized that it would be very nice if instead of having your editor do a half-assed job of trying to parse your programming language files, if you had your compiler do a really great job of parsing your files, and if there was a protocol that your editor used to speak to your compiler in order to have the two of them agree on the content of a file and on things like what the symbols are, you know, being able to get information for code completion and refactoring, etc. And Emacs, at least to some extent, now has LSP support, and this has changed the game for people using Emacs for all sorts of programming tasks. Unfortunately, LSP support does not come in the box with Emacs. However, since Emacs is used extensively by programmers, I think that language server protocol support should ship with Emacs so that all language mode authors can assume that Emacs's base libraries have support for LSP in them. Right now, LSP is implemented outside of Emacs as an extension. It's a wonderful thing that that's possible. I think it belongs in the base code. I think LSP needs to get integrated into everything for a maximally pleasurable programming experience going forward. Now, the good part is that fast JSON parsing, which is necessary to make LSP really, really sing, is in Emacs 27 already. This is a big win for performance for LSP users. Another thing that we need, on top of integrating LSP directly in Emacs, is we need better and better language support modes that use LSP. Though that seems to be happening on its own, not something we really need to encourage the community to do much. The community is doing it. The next big thing that probably needs to be addressed is LSP's sibling, the debug adapter protocol, which will allow modern debuggers to talk to Emacs, and which is a thing that exists sort of the way that LSP does. It's a mechanism by which IDEs and editors can talk to language-aware debuggers without having to build support for every debugger in every editor. Now, many people often complain that Emacs is too much of an operating system, and they make cracks about the fact that they only like writing using one operating system at a time. I contend that Emacs should be more of an operating system, and that people who don't think of it as an operating system are missing out. Now, when I gave my last talk, Emacs always blocked all windows when doing computing in any given window, which was a really big pain in the neck. And in fact, I still often run multiple Emacs's to get around this problem, which is, you know, makes me sad. Thread support in Emacs can help with this, but ultimately, in order for thread support to be used pervasively throughout Emacs, and for people to be able to constantly switch Emacs windows and Emacs frames and what have you while computation is going on, we need a concurrency model throughout Emacs, you know, and that's programmer friendly and that is pervasively implemented. I've already talked a bunch about that. It's necessary if more people are going to live inside of Emacs for everything they do all day long. Now, about email again. It's been over a decade now since I read my email inside of Emacs, a thing that pisses me off every single day when I find myself wanting to edit email messages and and not having Emacs there as the way that I edit my email messages, because why would you ever want to edit text in anything else? For me to be able to use Emacs to read my email every day, one needs two things. One needs better IMAP-oriented email modes. Mew and Wanderlust are the two modes available for Emacs that are actually IMAP-aware, but both of them are poorly documented and poorly maintained these days. And one needs HTML email rendering. These are things that can be fixed. If the HTML rendering problem gets fixed, the rest is a simple matter of programming and documenting. So let me again encourage people to fix the HTML rendering problem. Now, another thing that has happened over the decades is that one time Emacs was the best way I knew to have a personal information manager to maintain my calendar, my appointments, my contacts. This is no longer the case. People's day-to-day operating systems usually have personal information managers integrated. People's day-to-day operating systems usually have, appointment and contact systems that one wants to be able to integrate with if one wants to be able to function day to day. I need to view my calendar on my desktop, on my phone, on my other desktop, etc. So that means that I want Emacs's calendar modes to do CalDAV. I want Emacs's contacts management modes to do CardDAV. I want org integrated with CalDAV and with CardDAV. And I would like underlying protocol tools that do all of this stuff to be abstracted so that many modes can take advantage of implementations of things like CalDAV and CardDAV, and for that matter, of IMAP and other sorts of protocols that might be pervasively used by many Emacs productivity modes. A small digression. Lots of people use Markdown all day long now for documenting their code and for doing rich text work. If you are a text-oriented hacker type, Markdown is a beautiful thing. And there is, of course, also org, which is kind of like Markdown, and many of the reasons that people like org are the same reasons people like working with Markdown. It should be possible, or here's a question, should it be possible to view org and Markdown comments, documents, etc., as not just as source, but as rendered anytime you're reading an Emacs buffer? If you want to, should you be able to set a mode where you see your Markdown or org comments inside of your program source code as rendered or as source, very, very freely moving between the two of them? I think that's probably something that people want, something that I'm going to mention. Another digression. Org mode is really, really addictive to lots of people these days. But RMS once noted something on the developers' mailing list that I think is pretty important, which is that there's an architectural problem with org. Org mode is kind of this separate set of stuff that you add on to the side of Emacs, and it lives kind of on its own. It's not integrated all over everywhere inside of Emacs, and I think that's a shame. Org provides all sorts of facilities, everything from being able to edit spreadsheets to being able to view rich text and rich text and programs all over the place. I think that org should be pervasively integrated. Maybe other people disagree. I think it's a thing that people should be thinking about going forward. Now, I'm running low on time, so I'm going to skip through some of the next things rather fast. First of all, I think we need better chat clients available for Emacs. IRC is getting rusty, which is why people are moving to all of these things like Slack and Discord, which are not Libre and don't really run inside of Emacs. Fixing a part of this is going to require having facilities inside of Emacs for writing better chat clients and systems, but a large part of it is going to require that people understand what it means to build open chat protocols, which does not mean creating a website with an API. It means learning how people build distributed protocols. Never mind, skipping past that quickly. I've now finally reached the end of the major part of this. I'm going to have a brief rant, and then I'm going to end the talk. And the rant is about hacker-friendly user interfaces. Now, I use a Mac all day long. Don't hiss at me. I use a Mac all day long. One of the reasons that I use a Mac all day long is Macs support Emacs better than GNU Linux does, or at least better than the average user interface on top of GNU Linux. This is really true, and this is really a shame. On macOS, every input widget I deal with, the text input widgets in my, in random text editors, the text input widgets in various, inside of my web browser windows, inside of, the GUI calendar, everywhere, except Emacs keyboard commands. Not if you configure them that way. By default, without configuring anything, they accept Emacs commands. By contrast, I have never, ever figured out how to get GNOME or KDE to take Control-F, Control-P, Control-B, Control-A, Control-E. Why is this? This is kind of shameful, and I've tried fairly hard. And these are supposedly systems built by hackers. Emacs support is on, and on by default in macOS, and might not even exist in GNOME and KDE. So the supposedly self-declared geek-friendly operating systems are less geek-friendly for the addicted Emacs user than the closed-source operating system that no one should be using. People seem to keep focusing, when building GUIs for the desktop, when building Windows systems for the Linux desktop, they keep focusing on random users who are not using such systems at all. Let's stop sacrificing usability for hackers. To win, Libre software, free software, needs developers, which means that such software needs users who are hackers, because hackers fix their own tools. So hackers using Libre platforms means hackers improving the Libre platforms, and a Libre platform needs to be hacker-friendly for me to want to use it. And as I said, people these days seem to build Libre desktop environments to be friendly only for normal users and not for hackers. They're more like using Notepad for me than they are like using Emacs. So why would I want to use them? Why do I want to use GNOME when it is worse as a user experience for me than using macOS is? That's kind of ironic, but it's true. I don't use Notepad, and I don't use GNOME or KDE. Maximal productivity for hackers is not the same as being strictly user-friendly for normal people. Productivity for me means Emacs-like interfaces, and I want everything that I use to have an Emacs-like interface. I want a desktop built for geeks. I want to make Emacs's user interface swallow everything. Now, one way of doing this would be literally using Emacs for everything. Using Emacs for mail, using Emacs for the web, using Emacs as my personal information manager, using Emacs for chat, using Emacs for, I guess, editing here and there. But that's not the only way to do such things. I certainly want that to be the case. I want Emacs to be good at all of those things, but there are going to be other programs that I'm going to use day to day, and there's going to be a Windows system that I'm going to be using day to day, and I would like that to be more like Emacs too. I would like all of the UI text widgets I deal with on my desktop day to day to take Emacs commands. I want to have a mini buffer window in my window manager. When I hit menu X or something like that in my window manager, I want it to open a mini buffer and allow me to type in commands and have it go away when I hit return. I want to have Emacs-like commands be the best way to do everything on my desktop. And I really do mean everything, and I really do mean the best way. Sure, it should be possible to use the mouse for things, but I want the best way to do things to be the keyboard. and I want my entire user interface to be extendable in an extension language. Hopefully the same one that Emacs uses, but it doesn't have to be. Now, another real quick digression. These days, keyboards have become remarkably user-unfriendly for Emacs users. This is a slightly older Mac-style keyboard. You will notice at the bottom that Control, Option, and Command, and Option and Command might, Command might be your meta key, Option might be your meta key, it doesn't matter. The point is, your Shift keys are symmetric on both sides of your spacebar. It is easy to hit them using either hand. These days, however, laptop and desktop keyboards tend to look more like this, with an asymmetric layout, without Control and Meta and other keys like it, symmetrically available on both sides of the keyboard. This is bad. We luckily live in a world where people get an opportunity to build their own keyboards these days, where there are a large number of choices in commercial keyboards. But if you are out there and have influence on keyboard design at any company, please remember that the Emacs users in your life want to be able to hit things like Control with either hand. And talking a little bit more about this, I hate the fact that my keyboard doesn't let me enter in anything that wasn't in the ASCII character set in 1966. This seems a little bit silly, especially when we live in a Unicode world, and where things like not equals or less than or equal to, or for all, or set inclusion and other things like this that programmers might want are fully available inside of the Unicode character set. I want to go back to the future. I want keyboards that perhaps don't look so much like this Space Cadet keyboard from 25, 30 years ago, but which have a lot more of the features that it does. In particular, I want a keyboard where I have shift keys that allow me to enter far more math characters and far more programming characters than a current keyboard lets me enter, and which give me more shift keys, like hyper and super and what have you, than a normal modern keyboard does, so that I can use those with my Emacs-like user interface across my entire desktop. Anyway, I've just about run out of time, but luckily I've almost just about run out of things to discuss today. So just to summarize, what's my priority list for improving Emacs? In the near term, my top priority is HTML rendering. I would like to see LSP support integrated straight into Emacs so that all programming modes support it. Sometime soon, I'd like to see more modern email, personal information management support, etc. That can be done by various people who are interested, and might be done more by various people who are interested if there's HTML rendering in Emacs. In the long term, I want to see a really good concurrency model and a better extension language for Emacs. That's going to be a very long-term slog, but there's no better time than the present to get started thinking about it, because it's going to take a long time to do. And with that, I will, open for questions, at least as soon as this recording stops and I show up on the, in the chat channel.